In the last lecture, we have discussed about the hitches like bridle hitch, basket hitch, and choker hitch. In today's lecture, we will discuss about hybrid hitch. Hybrid hitch basically a combination of bridle hitch with either basket hitch or bridle hitch with either choker hitch. So let's start our lecture. In this lecture, we will understand how the combined reduction factor is calculated, how it affects the working load limit. So let's start. The first example in front of you is basically one of the beam is lifted. Okay, so here you can easily see if there are lifting legs are there, if there is a provision of lifting leg over there, then definitely it is simple. If this lifting leg is over there, then it is basically simple, bridle hitch will be there. Okay, the two lifting point and the crane CG will be over this, but here there is no provision of the lifting leg. So what it is basically combination, this is basically bridle, this is bridle, and this one is basically choker, this one is basically choker. So it is basically a combination of bridle hitch plus choker hitch. So let's understand how we have to calculate the reduction factor. Now this is before lifting. Before lifting, it is basically simple loosen up. But when we lift up because of the friction, it automatically gets its natural shape. Okay. So now this sling is basically tightened up. This is basically tightened up. Okay. Now it is tightened up. So before lifting it is loosened up, but after, as it is a choker, after lifting it getting tightened up. So it is basically a combination of bridle plus choker. Now if we understand this, so this is the simple basic diagram of this. Suppose we are lifting a weight of 10 metric ton. Okay, and this total weight is going up to 10 metric ton, and this combination is basically bridle combination, this combination, and that as it is a case of the CG lifting, then load coming on each sling is basically each side is coming out to be 5 metric ton. So lift weight is 10 metric ton, and on the both side it is 10 by 2 is 5 metric ton. Here it is a case of bridle. We will bifurcate into two parts. One is the bridle hitch calculation and the other is the choker hitch calculation. Okay, in the bridle hitch calculation, the bridle hitch angle is 60 degree, the including angle, that is basically 60 degree, this angle is over, and choker angle, the natural choker angle is 120 degree, and we are using the sling of dia 1 inch. Okay, and the weight coming is 5 metric ton on each. Now we already know that the sling dia is 1 inch, then SWL using the formula 8 into d square, 8 into 1 into 1, that is basically 8 metric ton. Now working load limit, it is a combination of two. One is basically this bridle and the other is basically choker. So we have to multiply the SWL of the wire 8 into d square with the reduction factor. There are two reduction factor come into picture. The K1 is due to the bridle and K3 is due to the choker. Now K1 is due to the bridle, as you remember the last lecture, K1 is basically the sine of the included angle. So here the K1 is basically sine of the 60 degree, and sine of 60 degree is 0.866. Okay, and 0.866. And now here the choker angle is 120 degree. If you remember the last lectures or the last classes, if the choker angle is between there is a choker hitch angle reduction factor based upon the angle. So if this is the range 105 to 120 degree 0.82, 90 to 105 degree 0.71. Here it is 120 degree, then we will take reduction factor 0.82. Okay, so here we have taken the reduction factor as 0.82. Again, K1 is reduction factor due to bridle hitch and K3 is reduction factor due to choker hitch. Okay, so K1 is 0.866 and K3 is 0.82. We are using a sling of diameter 1 inch. Then SWL is 8 into d square. So working load limit, the combined working load limit is comes out to be 8 into reduction factor 1 and reduction factor 2. That is K1 into K3, and it comes out to be 5.680. Now the weight coming on the each side is basically 5 metric ton, and the safe load working load limit is comes out to be 5.6 is greater than 5. That means this sling configuration is safe for us. Okay, so we can go with that. This is the case. This is the first case. Now suppose someone give you another example, and here you have to calculate. It's the same question that we are following up. But here you have to calculate at what angle you have to bind this sling up so that this arrangement is safe. And now the weight that you are lifting up is not 10, it is 12 metric ton. Okay, the weight is 12 metric ton. So it is coming on the each side is 6 metric ton, 6 metric ton. Now we have to do the reverse. Okay, WLL is given by SWL into K1 into K3. K1 is the reduction factor due to Bradle hitch, K3 is the reduction factor due to choker hitch. Okay, this K1 is given by WLL over SWL into K3. WLL, the maximum load that is coming is 6 metric ton. We have to be working load limit is 6 metric ton. So we have taken WLL as 6. SWL is 8 into D square. The sling we are using of 1 inch diameter, that is 8. And this K3 is already we have this choker angle is 120 degree. Here again the choker angle is 120 degree, but we have to find the Bradle hitch angle. It is a natural choking angle. If you are getting tight, then it generally comes out to be 120 degree. So then it comes out to be K3 is equal to, for 120 degree, it is 0.82. So in this manner, you can easily find out this value. K1 is equal to 0.195. Theta is equal to sin inverse 0.95. Theta is equal to 66.2 degree. So up to the angle 66.2 degree, it is safe to use this 1 inch diameter sling. Okay, below this it will fail up. Okay, so for the lifting of 6 metric ton, it is okay. Understand? Basically, you have to combine how you have to find the working load limit. WLL is equal to SWL into reduction factor 1 into reduction factor 2. Okay, Bradle ka reduction factor, and then this is the choker reduction factor. If you want to find anything, just put the weight you are lifting up, that is basically coming on the sling. You can take it that value, and you can identify the factors that you have to maintain, or either if you have some factors over there, you have some angles over there, you can calculate the WLL. So this is the basic funda over there. Okay, now we will move further. This combination is basically we are lifting a shaft or some shaft drum. Basically it is some rotational part over there. As it is rotational part, is very difficult to have some lifting lug over there. So what we do, with the help of the spreader beam, we are basically lifting up, but this connection is, again, one is basically this Bradle and the other one is basically this basket. It is not choker. So it is combination of Bradle hitch plus basket hitch. Okay, got it? If you remember the last lecture, in the basket is what matters is capital D by small d ratio. Okay, so for the above it is clear. 100, the weight is 100 metric ton. Here the diameter, basket, for the diameter, the wire of sling is of 2 inch diameter. The basket angle is 75 degree, and this diameter of this main, this circular shaft that you are lifting up, it is 160. Okay, now vertical load lifting 100 metric ton, as these are two combination there. So on the one side it is coming out to be 50 metric ton. So again there are two things, one is the Bradle and the other is the basket. So we have to combine the reduction factor. Again, SWL or WLL is equal to SWL into reduction factor due to Bradle plus reduction into reduction factor due to basket. Okay, now the load is 100 by 250 metric ton. Bradle sling angle is 75 degree. Okay, as you can see, this angle is 75 degree. This angle is 75 degree. 75 degree. This angle. Okay, this angle is 75 degree. Okay, so the reduction factor is simple. Sin theta K1 due to K1 reduction factor due to what? Bradle. Sin theta sin 75 degree, that is 0.97. Okay, diameter of the wire of sling is 2 mm. So SWL is equal to 8 into 2 into 2, that is 32 metric ton. Now when we come to this part, basket part, then ratio we have to find R is equal to capital D by D, that is 160 by 2, that is 80. If you remember the last lecture, there is our formulas over there. If the R is greater than 6 or R is greater than 6, there are formulas over there. As here the R is greater than 6, the formula comes out to be efficiency factor is E is equal to 100 minus 50 divided by R ki power 0.75. So in this manner the efficiency calculate out to be 98%. From this efficiency we have to find the reduction factor, and the formula is K2 reduction factor due to this basket is basically K2 is equal to 2 into E by 100. E is basically efficiency. Okay, and as we have already calculated, efficiency come out to be 98%. If you doesn't getting these formula, so you have to go to the past lecture, then you are able to understand it. So 2 into 98 by 100, it comes out to be 1.96. Now again the same concept, 8 into D square, 8 into 2 into 2, 32. K1 reduction factor due to Bradle 0.97, and reduction factor due to this basket, that is 1.96. So it comes out to be 60.83. It is 60.83 is greater than 50. This means our condition is safe. We can easily lift up. Okay, in this manner we are calculating up. Now another example is basically this is a combination of Bradle plus basket. Okay, now there is here You have already understand this thing na? Bridle plus basket. Okay, here we are using what we are using. This is a basically some special case. Okay, here the thing is that these are basically, these are one set of slings. These are one set of slings. One, two, three, four. These four slings are over there. Then again there is a D shackle over there. There is a D shackle over there. This at the end of this sling there is a Z shackle over there. At this D shackle, it is wrapping around. It is having the basket. The basket is wrapping around and it is again fixing up. Okay. Okay. So here you are using 1, 2, 3, 4, 5, 6, 7, 8. If we are using single sling and having the basket, then the length of the sling will be very much, and it is not feasible. So this is the best combination. What we have, we are using 4 sling as the bridle and the other 4 slings as the basket, and they are combined. They are together combined with the help of a D shackle that is having 55 metric ton. Okay, so this is basically each leg consists of what? Each leg consists of, one is the bridle, one is the basket, and one is the shackle. Okay, now each leg is having a bridle, each leg is having a basket, each having a shackle. So if you want to basically identify how we are able to get the sling dia, or we are able to find the safest condition, then we have to always go for the weakest link. इन तीनों में से सबसे weak कौन सा है? Which is the weaker? Bridle, basket, shackle. Which is the weaker? We have to check that. Okay, if the weakest link is satisfy the criteria of the lifting, then the other will easily satisfy. Okay, so this combination is basically like this. Okay, if you go into the detail, this combination is like this. First here is basically the load is 100 metric ton and there is a 4 sling, one green one, 1, 2, 3, 4. Okay, 4 sling, the load coming on each sling is 25 metric ton. Now this white is D shackle, D shackle, D shackle, D shackle, and this D shackle, this again, this sling is having a bridle. Oh, this basket hitch over there. Okay, basket hitch. So it is simple like this. Hope it is clear. Okay, now we will understand. Now here this is combined bridle, this is combined bridle, this is combined bridle, this is combined bridle. So here the including angle is 60 degree. Okay, this is clear. This is including angle is 60 degree. Again, these are below is like this basket. In the case of basket, again it is basically bridle plus basket. Okay, here the angle is 85 degree. Here the angle is 85 degree. Okay, now here they are basically reduction factor 1 due to bridle. One is the reduction factor, primary reduction factor, that is due to this angle, that is sin 60 degree, sin 60 degree, that is 0.87. The second is due to this 85 degree angle, this including angle, that is secondary reduction factor, sin 85, that is 0.99. Okay, here we are taking the bridle into 2 cases because these are 2 different slings. This is having this and this is having this. So basically one is like this, arrangement is like this. If you understand, दिस इज द अरेंजमेंट लाइक दिस. यहाँ तक गया, इसके बाद ये यहाँ पे गया, तो एक एंगल ये वाला बन रहा है. दिस एंगल, वन इज द एंगल दिस ब्राइडल एंड दिस इज अगेन अनदर एंगल that is also form of the bridle. So here the reduction factor is due to this angle, here the reduction factor is due to this angle. Okay, one is the primary and the other one is the secondary. The primary comes out to be 60 degree, sin 60 degree is 0.87. Secondary is again sin 85 degree, that is 0.99. These two reduction factors, now we are okay. Now we have to find the another reduction factor due to D by D ratio, that is basically the basket, that is 2 into E by 100. So the formula we are using of D by D as less than 6, then we have to use the formula 100 minus 50 divided by R की power 0.5. You already, if you want to understand this formula, then please go through the last lecture. You are able to understand how this formula comes, basically how these formulas are presented. Okay, so you can easily go through the last lecture and understand. Okay, now so first one is the primary due to this primary reduction factor, due to this second reduction factor, and due to this basket arrangement another final reduction factor due to basket. Okay, so here in this case, if we talk about this sling, this less SWL is equal to 8 into D square into primary reduction factors. Here coming out to be primary reduction factor, that comes out to be primary reduction factor is this sin 60 degree, so that comes out to be 27.8 metric ton. So this sling having the load of the WLL of 27.8 metric ton. Okay, Now we are talking about this sling, the this that is getting choker up, that is basically basket, this basket, that is making the basket. Okay, 8 into d square into secondary factor into basket factor, so it comes out to be 42.66, and there is a d shackle that is of 55 metric ton. It is basically simple. You have to just, whatever the combination, you just have to find the reduction factor of each combination. Here first is the sling, that are 4 slings, there is a reduction factor, prime reduction factor. Now this basket is also having some angle, so there is also forming a bridle shape, then there is also reduction factor due to that angle. And also as we are having a basket condition, then there will be reduction factor due to basket. So there are 3 reduction factor. Okay, so in this way this sling comes out to be 27.8 metric ton, this is 55 metric ton, this is 42.66 metric ton. The working load limit comes out to be like this. Okay, now these are the 3 having 27.8 metric ton, 55 and 40.6. Which is the weakest? That is 27.8 metric ton is the weakest. And what is the load coming on each sling? 25 metric ton. It means we are safe. Okay, so in this manner you are able to understand, you are able to get the combined reduction factor, and you are able to calculate the slinging arrangement. Hope you like this lecture. Keep support and subscribe. Thank you.